Hello guys, today we are going to learn more about the DB, right? And this is the phase 3 in the DBS part. And as here we can see, we are going to learn about the DB monitoring metrics today. And as per here, already we have about one, two, three, four, five, six monitoring metrics which we can utilize while we are maintaining a DB. First comes the IOPS. Before getting into these metrics, we are going to see what are these metrics, and after that we are going to make a demo using Postgres DB and also MongoDB and generate load on them and see how these metrics are changing when we are generating the load. Okay, so now let us get into the explanation. Right, first let us go through the IOPS. IOPS, which means that input output per second. So our DB has a memory, or our server has a memory. So we will be writing and reading data into our server or our DB or our disk, right? So how many inputs and outputs, I mean how many writes and reads we can do to our disk in a second, such that if it is more we can do so many read and writes for per a second. So let us say we have a DB and it has been taking 1 million queries per, per second, and we are doing in this 500,000, sorry, 50,000, let us say half of the million reads and half million writes. And these reads and writes are being done for every second. So if our DB is accepting 2 million, or DB or disk, right? 2 million IOPS. So this will be done very easily without any load, because it is only the half load which is accepting. Let us say now we have 3 million queries per second, but we have only 2 million IOPS. So now the DB load will be increased, and there is a possibility that disk is crashed, or the IO will be blocked. Input output will be blocked for some time, which will be stacking the queries, and we will be executing queries very in less latency. This will be causing so many problems. So let us say if you are monitoring these metrics daily, and let us say it is crossing the limit, so we can note that this is crossing the limit before our DB is crash or DB will crash. We will be updating our DB metrics like vertical scaling or horizontal scaling, such that there will be another DB added as an extension, so the load will be decreased. So this is regarding the IOPS. Coming to the next metric, which is CPU. So our DB or our disk will be taking the inputs and outputs, and to do this operation, we need a processing power, as in every system or every server. Processing power. So here the processing power is CPU, central processing unit, and we are taking some of this processing power to do the operations, right? So let us say we have our CPU can accept about 500,000 parallel operations, but we are doing 1 million parallel ops. So this will crash the CPU. So based on our user load or our customer things, so we'll be analyzing these operations, how many operations are done daily, such that do we increase the processing power, add more cores, add replace another CPU, etc. So we'll know regarding the CPU metrics. Got it? And there will be percentage of the CPU will be used. For example, let us say our CPU is 100% or 200% based on our cores. One core equal to 100%. So if you have 8 cores, it will be 800% and stuff. Okay. Now let us say our CPU is being used 200% when you have 4 cores, then it is okay. But it is used being 300% or 350%, then we have to increase our cores or replace our CPU. That is one thing. So this is regarding the CPU. Next comes memory, in other words RAM. So we will be taking the RAM for doing the operations like parallel queries, cache operations, etc. So our DB will be having a connection limit, let us say for example now 30. So our DB can now handle parallel of 30 connections, which means that only 30 users can use our application, or 30 users can connect to our DB parallelly. Let us say you have a URL for the DB and you have a connector like PopSQL to connect to the SQLDB, and there are only 30 people who can connect to this URL. So, to manage the operations or to manage the queries which are done by these 30 people parallelly, we will be using memory such that we will do parallel operations, do cache such that we can return the results which are being queried more, etc. So, if you have 8 GB memory and you are using 7 GB of it, which means that we need to do vertical scaling, which we have discussed earlier in the before video, and we have to increase the RAM from 8 to 16 or to 32. So which will reduce our memory load and will make our application run smoothly. And next comes the metric, storage, right? So let us say we have a table of about 20 columns, which is very bad. Okay, because we need to split the tables, split the columns based on the normalization and stuff. But let us say for now we have a table and it has 20 columns, and we are storing so much data, like we are doing storing like varchar of 256 or something. So, and we are storing very large text in it. So now our storage is let us say 10 GB. For 1 million rows, it occupies 1 GB. Let us say like that. Okay. Now we are daily entering 500,000 rows. Okay. So in this scenario, 1 million rows occupies 1 GB and 500,000 rows we are entering daily. Our DB will be full in about 20 days. And if you make the 500,000 rows right in next day, our DB will be crashed because the storage is full. Got it? So this is also another metric to monitor how much is our storage left, and do we need to scale it like vertical scaling, increase the disk, mount another disk for this, such that the storage will be increased and stuff, right? So this is regarding the storage. And last comes connection limit and slow queries. Regarding the connection limit, let us say we have been using microservices and we have about 5 microservices. Got it? And there is a single link. Okay, and our DB connection limit is 4. So we have split this backend servers as 5 microservices that such that the users can access our backend server seamlessly and more load can be handled. And our DB connection limit is only 4. So let us say 5 users, let us say 25 users came, and 5 users are divided to every microservice. So this will ping the DB, this will ping the DB regarding the query, and this will come the ping the DB regarding the query, and this will ping the DB regarding the query. Now the 4 connection limit is exited, and this fifth one comes and waits for the one of the fourth connection to exit, and so the 5 users which are accessing this microservice will be waited. So we have to enlist this also as one of the metrics. So if there are so many parallel connections, our DB will be loaded, and we have to accommodate a very bigger DB, or increase the threads which will help us to do the parallel queries or parallel connections. Got it? And at last, slow queries, right? So let us say we are doing a very big query which are joining two tables with separate conditions, and which is a very complex query, and this requires more of the CPU time, more of the memory, more of the parallel connections and RAM and cache. But so many users are coming to our DB, and this is blocking the small queries which are doing after this. Okay, so in this thing we will do slow queries which will be done in background with less like parallel thing. But let us say we have small query 1 and this big query 1. So and small query 2 is also there. This big query takes 5 seconds, small query takes 1 second, right? So the big query will be running in background, and it will be running by no assumption and stuff, but the small queries will come and go. So there will be no pausing of the normal queries, but the slow queries will be running later, such that the load can be handled. So these are the different metrics which can be handled in the DB. Okay. Now, yeah. So now let us get into the demo, and I have given the notes which I have explained until now. What are these metrics to? What do these do and stuff in this thing, and we are going to now monitor using the Docker stats and also the PG stat activity. But in further things to analyze more and stuff, we have to monitor using some tools like Datadog and also Prometheus and Grafana. So for now, let us do it, and in the upcoming phases, we'll eventually do with the Prometheus and Grafana. So for now, there are no Docker containers running now. Docker PS. So I have created a Docker Compose file such that you can start up two containers. One is Postgres and one is MongoDB, and execute load testing load on them such that we can test them. Okay. For now, let us do Docker Compose up to spin up the two Docker containers. One is Mongo and another is Postgres. As the images are not there in local, we are pulling the images from the internet and we are going to run the images now. Meanwhile, let us see the queries we are going doing. Here we are connecting to the Postgres container, Docker execute PG container, and we are logging in as a user for the test DB, and we are creating a table if it is not there. And after that, we are parallelly running 200 queries. Okay, and coming to the MongoDB, which is similar, we are importing the Mongo client. Guys, if you are running this, please do npm i because we are running MongoDB and we need to install it before. We need to install this package. So we are connecting to our localhost MongoDB and also connecting to the DB, connecting to the collection name. And after that, we are running 20,000 parallel queries, right? So I will explain you why we are doing this. Let the Docker container spin up. Okay. Now we will be doing parallel all promises, and we will be doing this parallelly because we are running all promises at a time, and we are creating these promises, right? So, and if we are getting any log errors, we are console.log. So these are two scripts. One is load postgres.sh and another one is load mongo.sh. So now let us run it, guys. So as we can see, these are the metrics or logs which are coming from the PG container, which is the Postgres, and Mongo container from the MongoDB. Right now, let us execute Docker stats such that we can do. So yeah, Docker stats. I have done Docker stats. So yeah, as we can see, our CPU is very less now. We are using the memory of only 67 MB and 203 MB. As you can observe, guys, MongoDB requires more RAM, and here also mem usage, right, out of in a percentage thing. So yeah, as you can see, this is very less memory, so 0.85 and 2.57, and these are the network IO operations, which mean that the number of network requests which came and which will go, and this IO, which means that input output operations which you have mentioned, and these are the process IDs, which is 6 and 30. These will be defining the threads which can be run parallelly. So we have only 6 here, but we have 30 here, and that's why we will be running 20,000 queries parallel, 20,000 insertions parallel in MongoDB, and only 200 insertions in Postgres. Got it? That's why I have put the difference between 200 and 20,000 in the scripts, right? Now another thing we can do is we have to log into PostgreSQL to see the activity. So let us copy this, and we have to make it interactive such that we can execute the queries. So let us change this to ID instead of I. Okay. Now we have logged into the PostgreSQL and let us say DT. There are no tables, right? So now let us clear it and let us first show you the metrics by running the Postgres script. Okay, here we have the Postgres script dot by load underscore Postgres dot sh. As soon as we click enter, we will go to the Docker stats tab and we will see the stats. Now let us see this, guys. Observe this. The CPU is increased, the memory usage is increased, right? It is being stucking, right, because we are executing so many things, and you can see the PIDs, how many parallel things we are running, as it is 200 queries, process IDs, and the CPU is 115 percentage usage, right? As the network operations will be like that only because we are not pinging it from outside. As you can see, it is 8 only and it is reduced again, and now it is normal, and as we can see the execution is done and we have inserted queries. Okay, now there is another query we need to execute, which is selecting all the stats from the PG stat activity, which is a default table which will be present in the Postgres. Let us take this so that we can see the query very nice. Okay, as you can see, this is the query start time, and this is the query we have been executing. Now we are going to execute this query again and again until we see something from the insertions which we are doing. Got it? Now let us execute the query, and again let us go to the tab and do our stuff. Okay, let us see if anything comes up. Yeah, got it. As it is parallel queries, we will be not able to grab it at the same time, right? As we can see that we are generating the numbers in the script and we are inserting them, right? So we are able to grab 76, 95, 143 queries here. If it is, if they are sequential, it will be very easy to catch them. But yeah, as we can see, these are the queries which are going on now present at the time. So now we have seen the Docker stats, and now we have seen the PG activity. Postgres is done. Now let us go to the MongoDB and execute that MongoDB script. Okay. Shit. I'm very bad at spelling mistakes. Okay. Load mongo.js. Okay. Now we will do node load mongo.js. Shit. Something happened. Yes. I have mentioned, right. We have to do npm I. Now we have installed the packages. See, the CPU is also increased the 44%. The memory we are using the PIDs and the network activity. As observe one thing, guys, we have connected to the Postgres container through the shell, so there is no network activity. We are directly executing the queries on it. But here we are connecting through a Mongo client, which is imported from the Node.js modules, which will connect using the network, which is the local host, right? We are giving the URL here and we are connecting to it, and we have seen the network IO activity here. So right, that is also one thing to observe. So I will run the query again such that you can observe again. So the CPU is increased, the network activity is increased, the memory usage is also increased, and the block IO is changing. Right, now again let's execute it, and also let's observe the PG stats again. Yeah, as we can see, it is increased to 106 and stuff. And yeah, now another thing I wanted to show but I forgot is the DB. As we can see, before there are no tables, now we have the table. And I think we have executed about 3 times or 4 times, I don't remember. So from load test semicolon, so I think we have executed 2 times, right? So 200 rows, 200 rows, 400. Now again let's execute the Postgres thing, and let us see the activity again for our fun. Yeah, I think the operations are done. Now let us see the rows again. 600. As you can see, guys, it is working well and good. So the reason I am showing this in the GitHub code spaces is this requires a local Docker setup or a virtual machine in the cloud, which requires queries. I don't have both of them. That's why I'm showing you only this many queries. If I have a bigger VM, if I have a bigger RAM and stuff, I will be executing more parallel queries. So yeah, guys, yeah, this is about the database metrics. And if you like the video and if you understand the context, please like, share, and subscribe, guys. Thank you. And yeah, so I will be also pushing the commit to the DB phase 3, and I will be watching the main branch so that you can also see this scripts and the Docker Compose files. Thank you, guys.